Hi everyone. Today we're talking about percent change problems. So when we are talking about changing by percent, we're talking about increasing or decreasing a certain number by a particular amount. So in a typical percent change problem, I have some on the board here, we might be asking like, what is the percent change when we go from 100 to 120? Or what is the percent change when we go from 50 to 70 or something like that? It's kind of like finding a percent, which we did in another video, but we're talking about adding or subtracting that percent from our original starting amount. One thing to keep in mind is that remember that we always start at 100%. This will be important for more complex versions of this kind of question later on down the line, but it's important to remember that whatever your starting amount is always 100%. So if I were to change my percent by an increase of 10, that would be the equivalent of 110%. Same thing on the flip side, if I were to decrease my original number or percentage by, let's say, 25%, then that would be 100 minus 25 or 75% of my original. So when we're looking at these percent change problems, there's a basic formula that we're going to want to use. And this will help us out in all forms of this. And then I'm going to show you a little bit of a faster way at the end as well for certain types of problems. So whenever we're looking at a percent change problem, like the 100 going to 120 here, we always want to start with our ending number. So whatever number we ended up with is going to go first in our formula. We're going to subtract the number that we started with, and then we're going to divide the difference between the two by the number that we started with. So basically the ending number minus the starting number, and then all divided by the starting number. That doesn't matter whether your ending number is bigger or smaller than what you ended up with. All that means is that if you end up getting a negative number from this, it tells you that you got a percent decrease. So let's plug this first problem into this formula. So we went from 100 to 120, so we ended up at 120 minus 100, and then we're going to divide by 100. So looking at that, the difference between the top here, 120 minus 100, is going to give us 20 on top, and then divided by 100. So that gives me the decimal 0.2, or you should know that's 20%. So since this is a positive number, we can tell that we increased by 20% from our original. Let's try that again with the second problem. So going from 50 to 70, again, 70 goes first because we ended up with that number, minus 50. Then we're going to divide by 50. So 70 minus 50 is also 20 in this case, over 50, which simplifies to 2 over 5 or 0.4. So in this case, that's a 40% increase from going from 50 to 70. Now, this is an important point that I want to make here, and keep in mind that percents are always relative to whatever number you're basing it off of. So even in both cases, since we increased by the number 20 or the quantity of 20, because our starting points were different, the percentages are different. So 20 makes up a bigger part of the pie of 50 than it does of the number 100, which is why the percentage change from 50 to 70 is a greater percentage, even though we ultimately increased by the same amount for both of these problems. Now let's take a look at what this kind of a problem looks like in a word problem. So Samantha bought an item from a store for $80. The next week she saw the item listed for $100. How much did the store increase the price of the item? And again, we're talking about in percentage terms. So in this case, the final price here was $100. So remember, that's our ending number. That's going to go first. And then the original price was 80. So we subtract that and then divide by 80 because that's our reference number. So 100 minus 80 gives us 20 over 80. This simplifies to 2 over 8, which if we divide by 2 is 1/4 or 0.25. So that's 25%. So a price increase going from 80 to $100 is a 25% increase. Let's do one more of these problems, and then I'll show you one more example of a just regular problem asking us to increase by a certain percent. So in this case, we have a factory that produces 9,000 pieces of candy per day. And then after they upgraded, they're now producing 11,000 candies per day. So we want the increase in percent of the factory's production. So we ended up with 11,000. We're subtracting 9,000. And because we started with 9,000, we're going to divide by that same 9,000. So in this case, 11,000 minus 9,000, that gives us 2,000. And dividing by 9,000, that's the same as 2 divided by 9. So that gives us 22.2 repeating, or, well, 0.222 repeating, actually. But it's 22.2 repeating percent, or 0.22. So this is a 22.2% increase in our production. In our last problem here, we have an example where Cindy is trying to increase the amount of dog treats that she is selling. So in this problem, instead of having two numbers where we're trying to calculate the percentage difference, here we have been given a percentage that we want to increase the amount by. So this comes back to what I was mentioning before. Remember that we always start at 100% of our original amount. So if she's currently selling 30 treats per week, then that means that she is currently, or the 30 is currently 100% of her current sales. So if we are trying to increase that amount, then that means we are trying to increase the amount that she's selling by 15% to get 115% of her original. There's two different ways that we can do this type of problem. The first way is to just find 15% of the 30. So remember, we do that by taking the 15% and dividing it by 100. That gives us 0.15, and we multiply. So this is going to give us a little bit of a decimal. So we're going to have the round up because we can't sell part of a dog treat. But the general thing applies, or let's instead, to make this a little bit simpler, let's make this a 10% increase so that we keep with our whole numbers. So I'm going to change this problem a little bit to 10%. Which means that instead we're going to multiply by 0.1. So 30 times 0.1 gives us 3. So 3 is 10% of the 30, and then if I'm increasing the amount, then I add that back. to the 30 to get a total of 33 dog treats. The other way that we can do this is that we earlier figured out that a 10% increase is the same thing as 110% of our starting amount. So we could also just do the 30 and times by 1.1, and that's automatically going to give you the 33. It just saves you one step. Same thing on the flip side. If I wanted to do, say, the number 50 and do a decrease by 30%, I could do both of these in the same way as well. I could do 50 times 0.3, which is going to give me 15. Subtract that from the 50 to give me 35. Or I could say that a 30% decrease is 100 minus 30 to give me 70% of my original. And so I can do 50 times 0.7 to give me that 35 as well. Either of these methods work. Make sure to try them out and practice, and come back to this video if you have any questions.